Dear friends, today we will see the nature of the roots of the quadratic equation. We know the quadratic formula that x is equal to minus b plus minus root of b square minus 4ac upon 2a. Here there are three negative signs, and it is always taught that whenever there is a negative sign, be careful. It is a foe in the garb of friend. It stabs from the back. So always be careful in treating the negative sign. Here is a term under the square root sign, that is b square minus 4ac, and this term is called as the discriminant, and that is denoted by d is equal to b square minus 4ac. Therefore, d is the discriminant. Friends, if this d is greater than 0, then the equation has real and distinct roots. Always remember these three conditions. Second is that if d is equal to 0, then the equation has real and equal roots. And the third condition is that if d is less than 0, then the equation has no roots. It means if the discriminant is negative, then that equation has no roots. It means it has no solution. Dear friends, can you tell me then what is the condition for the real and distinct roots? Yes, if d is greater than 0, the equation has real and distinct roots. Can you tell me then what is the condition for real and equal roots? Yes, if d is equal to 0, then the equation has real and equal roots. What is the condition for no roots then? If discriminant is less than 0, that is, if discriminant is negative, then equation has no root. It means it has no solution. Friends, now we will see the examples. Take the first example, that is x square minus 5x plus 3 is equal to 0. Whether it has equal roots or no roots or the distinct roots, that we have to find. So we know that discriminant is equal to b square minus 4ac. Here a is the coefficient of x square, therefore a is 1. B is the coefficient of x, therefore b is equal to minus 5, and c is a constant term, therefore c is equal to 3. If you put these values into the formula, you get minus 5 whole square minus 4 into 1 into 3. We are substituting the values of b as minus 5, value of a as 1, and value of 3 as c. If you solve this, you get d is equal to 25 minus 12 minus 5 whole square, that is 25, 4 into 1 into 3, that product will be minus 12, and therefore minus 12, therefore 25 minus 12, that will be equal to 13, and therefore d is equal to 13. Since d is positive, it is greater than 0, and since d is greater than 0, the roots are real and distinct. Dear friends, take another example, 4x square minus 5x plus 3 is equal to 0. Here a is equal to 4, coefficient of x square, b is equal to minus 5, coefficient of x, and c is equal to 3, constant term. As d is equal to b square minus 4ac, substitute the values of a, b, and c in the formula, and you get d is equal to minus 5 whole square minus 4 into 4 into 3. After solving this, you get minus 5 whole square, that is 25, minus 4 into 4 into 3. This product you get as 32, and therefore minus 25 minus 32, that gives you minus 7. Therefore D is equal to minus 7, and since D is less than 0, can you tell me what is the nature of roots when D is less than 0? Yes, when D is less than 0, the equation has no real roots. Take one more example. 4x square minus 12x plus 9 is equal to 0. Discriminant is given by b square minus 4ac. Here a is equal to 4, b is equal to minus 12, and c is equal to 9. If you substitute these values in the formula, you get minus 12 whole square minus 4 into a is 4 into c is 9. After solving this, you get minus 12 whole square is 144 minus then 4 into 9, that product gives you 144, and therefore 144 minus 144, that will be equal to 0. And since D is 0, what will be the nature of roots then? Of course, when D is equal to 0, roots are real and equal. Dear friends, thank you very much.